Hello everyone, I am G. Karthik, working as a assistant professor IT department in Kongnadu College of Engineering and Technology. Today we are going to discuss about wireless LAN. So what is wireless LAN? So wireless LAN is a wireless local area network. So it is for a flexible data communication system for transferring the data in between source to destination through air medium. So using the radio frequency as a medium in a air medium, we're transferring the data from a transmitter to receiver. So instead of wired communication, we are using wires for transmitting the data from a source to destination. So instead of using wires, we are using a wireless. We are using the radio frequency as a source to transferring the data from a source to destination. So these are all the advantages in a wireless LAN. So installing speed and then simplicity and then installation flexibility and then reducing cost of ownership, mobility and then scalability. So no need of installation for system. So in system there is only Wi-Fi connection is enough for transmitting the data from a source to destination. And then flexibility. So there is um, more flexible instead of wired medium. We can take over the device anywhere, and then we can start for transferring the data, and then reducing the cost of ownership. So reducing the cost of ownership means that wired cost is less for wireless communication, and then mobility. So whatever infrastructure we can switch over the device from one place to another place, and then scalability. So that is one of another advantage. And then disadvantage is that cost and then signaling signal bleed over and then environmental conditions and then less capacity. These are all the disadvantages. So cost is that in wireless network cards cost 4 times more than the wired network. So wireless network cards that need to install in our system. So at the time only we can able to transfer the data. And then signal bleed over. Signal bleed over is that access point. So whatever infrastructure we have, so in that infrastructure definitely we should have a access point. With the help of that access point only we can receive the wireless connection to our system. And then environmental condition is that there is what we say, so there is more number of walls and then trees, so buildings. So we can this kind of things are available means, so little bit complex to receive the wireless connection. That is we call it as environmental conditions. And then less capacity compared to wired medium in wireless. So it is a less bandwidth, slower bandwidth only we can able to receive. So that not that much flexible related to the wired communication. That is we call it as a less capacity. So these are all the wireless LAN applications. So where are they are using this wireless LAN? So medical professionals, corporate education, and then temporary situations, airlines, security staff, and then emergency centers. So here they are using this wireless LAN applications. So moreover in corporate and then education side, definitely they have access point. With that, they can share the Wi-Fi to their employees. And then airlines we will already know. So in airlines they are using the walkie-talkie. So with that, they can transfer the flight informations. So that kind of informations we can use in airlines. And then emergency centers, and the emergency centers also in all the buildings there is so no need of wired uh, installations. At that situation definitely we need this wireless LAN applications. So these are all the several type of IEEE 802.11 standards. We can directly go to infrastructure. So this is the 802.11 infrastructure. There is a two type of infrastructures are available. So one is a infrastructure mode, another one is a ad hoc mode. So in this infrastructure mode, this type of situations are they can use only in organizations and then educational institutions. So this type of area they can use this infrastructure mode. because in a company we are receiving the internet. For example, so there is a several type of so internet companies are there. For example, so take it as any one of the company Maduram Infotech. For example, I am saying if they are Maduram Infotech means they are from there we are receiving the internet to our organization. So with that organization we are having the several type of access point. So directly that access point is connected to the wired LAN. So through that access point, there is a several number of systems. They can access the internet link through this access point. So this type of infrastructure we call it as a infrastructure mode. And then ad hoc mode, only the access point is there. With the help of that access point, the multiple systems are receiving the internet connections. So this type of thing we call it as ad hoc mode. So this ad hoc mode is that only the coverage range is very less. So within a 500 meters, the coverage range means within the 500 meters only they can receive the internet connections. Once they are exceeded the 500 meter means they should not receive the internet connections. That is we call it as a infrastructure and then ad hoc mode. So these are all the things they can use in infrastructure modes. So access point already we know access point is a station. So provide access to the distributed system. DS is called as a distributed system. So another thing is a basic service set. So basic service set is also called as a one type of stations. So controlled by the access point. The access point is under the control of basic service set. So another thing is a distributed system. So distributed system is that the system which is used to interconnect a set of basic service set to create an extended service set. So that is we called it as a distribution system. Next thing is a extended service set. So two or more number of basic service set is called as a extended service set. And then portal. So portal is that it is a one type of entity which is used to integrate the so non 802.11 network is called as a portal. So this is the WLAN topology for a Hoc network. So see here there is a several type of so mobiles are available within a coverage range, a certain coverage area range. If once the so mobile is got moved out of that coverage range means immediately so that mobile will disconnect from the corresponding network. This is we called it as a ad hoc network. So like that, there is a several type of networks they have created. So within the coverage area range, the mobiles can receive the internet connection. This type of thing we call it as a ad hoc network. And then infrastructure mode. This type of thing we call it as a infrastructure mode. So in this infrastructure mode, we are having the basic service set. So two or more basic service set, we call it as a extended service set. So in this one basic service, we having both mobiles and then we having the access point. With that access point, the mobile can receive the internet connections. So in the distributed system only, they are sharing the internet to both access points. So with the help of the access points, that corresponding infrastructure will share the internet to a multiple mobile stations. That is, we call it as a access points. And then where we are receiving the internet connection to our distributed systems. So we are so getting internet connection to our distributed system through the wired LAN. So with that wired LAN only, the distributed system sharing the internet to both access points. So they are explain about this infrastructure mode. So what are all the things available in that infrastructure? We already discussed basic service set, extended service set, and then distributed systems. So how much of bits to be allocated for a basic service set? So 6 byte, 48 byte identifier should be which is available in the basic service. Any one of the access point want to, sorry, any one of the mobile station want to connect it with our access point means, so we need that corresponding identifier. So with that identifier only, we can provide access to that corresponding mobile station. That is, we call it as a 48-bit identifier. And then extended service set we already know. So two or more number of basic service set, combination of two or more basic service set, we called it as a extended service set. So in this extended service set also we having the certain identifier, 32-bit character identifier. So this is also for a authentication purpose. So with that 32-bit character identifier only, we can provide access to the multiple basic service set. Again, they are explain about this distributed system and then infrastructure, sorry, ad hoc network. So this is the architecture for 802.11 protocol stack. So in this, so during the year of 1997 to 1999, so they're using the frequency hopping spectrum for transferring the data. So after that, they are using OFDM during the year of 1999. So orthogonal frequency division multiplexing. And then after that, in the 1919 also, they are again using the spread spectrum techniques. There is a different type of spread spectrum techniques are there. So direct sequence spread spectrum, and then orthogonal frequency division, frequency division multiplexing. Like that, there are several type of spread spectrum techniques they are using in 888 802.11b. So after that, they are upgraded architecture as 802.11g. So at the time, they are using the orthogonal frequency division multiplexing. So after that, again during the year of 2009, they are using the MIMO orthogonal frequency division multiplexing. So this protocol stack is divided into three types of layers. So the upper layers, they are we already discussed about the several type of layers in OSI, operating system interconnection, open system interconnection. In that they are discussed about the upper layers. So and then so the data link layer and then physical layer. In physical layer, through the physical layer only we are transferring all those datas. So that's why this all type of spectrum techniques are used in a physical layer. So these are all the sublayer protocols. So reliable data delivery will be available, and then access control and then security. This all type of parameters should be so used for this MAC layer. So this is a medium access control. So in this medium access control, there's two type of things they are discussed. One is a point coordination function, then a distributed coordination function. So here in this physical layer, so what are the spectrum techniques they are used in a different type of IEEE 802.11. So 802.11 max sublayer protocol. So in this we are discussed about the two types of problems, hidden terminal problem and then exposed terminal problem. So in this terminal problem only we are discuss about this. So previous layers point coordination function and distribution coordination function techniques. So what is we called it as a DCF, distributed coordination function. So DCF is called as a distributed coordination function. In this we are discuss about the CSMA bar CA technique, which is called carrier sense multiple access bar collision avoidance. So once it will senses the medium, so if the medium is free, it will start to transfer the data. So before that, it will send the signal RTS and then CTS signal will be sent to that medium. So this RTS CTS signal is that ready to send and then clear to send. So if the channel is free, the ready to signals the signal is sent to the PDM and then immediately it will start to transfer the data. So another thing is that we can include the DIFS. What is called as a DIFS? DIFS is called as a distributed coordination function interframe space. So for each and every information we are sending through the medium, so we should give a space for the data. So this we call it as a distributed coordination function interframe space. So another thing is called as a SIFS, short interframe space. So they are described briefly about this distributed coordination function. In this distributed coordination function, we already discussed. It will always senses the medium If the medium is free, it will send the RTA signal. So after that RTA signal, it will start to transmit the data. So for each and every data, it will give the short interframe space and then DIFS, distributed coordination function interface frame. That signal to be included. So after that, if we get a reply from the receiver side, so for that the conversation will be continued. So this is a technique they have followed for transmitting the data. The simple CSMA, carrier sense multiplexers. So we are transmitting the data for A, sends the data to D, so data and then acknowledgement, and then B, we are receiving acknowledgement from the so B to A, and then finally C, the signal is free, so we send the RTA signal, and then immediately we will start to transmit the data. So within this, wireless LAN is over. So thank you all.